Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Evaluating AI Performance. How to know if your AI is doing a good job. Imagine you've built a cool new feature for your app. How do you know if it actually works well for your users? You test it, right? Evaluating AI is exactly like that. It's how we check if our AI brain is doing what we designed it to do. And doing it well. Without evaluation, your AI could be making bad decisions. And you wouldn't even know it. It helps us understand its strengths, weaknesses, and how to make it better. Just like user feedback helps you improve your app. This is the most straightforward way to see if your AI is doing a good job. Accuracy simply tells you, out of all the questions I asked, how many did my AI answer correctly? Single quote. Developer's perspective. If your AI is trying to classify emails as spam or not spam, and you give it 100 emails, if it correctly identifies 90 of them, its accuracy is 90%. It's like a simple quiz score. 90/100ths correct. High accuracy usually means your AI is on the right track. But it doesn't tell the whole story, especially for more complex tasks where the cost of being wrong varies. Precision is about being specific and correct when your AI makes a positive prediction. Think of a spam filter. When it flags an email as spam, a positive prediction, you want it to be asterisk very precise. You don't want it to flag your important work emails as spam. Developer's perspective. High precision means that when your AI says, "This is a cat," it's almost certainly a cat. If your AI is identifying fraudulent transactions, high precision means that when it flags a transaction as fraudulent, there's a very high chance it actually is fraudulent. You want to avoid false positives, cases where the AI says, yes, but it's actually wrong. Recall is about catching all the relevant positive cases. It's about not missing anything important. Imagine a security camera trying to detect intruders. You want it to have high recall, you want it to catch every single intruder who enters. Even if it sometimes mistakenly flags a squirrel as an intruder. Developer's perspective. If your AI is trying to detect a rare disease, high recall means that it identifies almost everyone who actually has the disease. You want to avoid false negatives, cases where the AI says, no, but it should have said, yes. Sometimes, missing something crucial, like a disease or a fraud, is worse than a few false alarms. Often, improving precision might make recall worse. And vice versa. It's a trade-off. For example, a super strict spam filter, high precision, might miss some actual spam. Low recall. A very lenient one, high recall for spam, might flag important emails. Low precision. Developer's perspective. The F1 score is a single number that helps you balance both precision and recall. It's like a blended score that gives equal weight to being specific and catching everything. When you need your AI to be good at both, F1 score is a great metric to look at. A high F1 score means your AI is doing a good job of both avoiding false alarms and not missing important things. While numbers like accuracy or F1 score are great, sometimes you want to see the raw breakdown of how your AI performed. That's where the confusion matrix comes in. Developer's perspective. Imagine a table. On one side, you have what the AI predicted, and on the other, you have what the answer actually was. This table shows you true positives. TP. AI said yes, and it was yes. Correct. True negatives. TN. AI said no, and it was no. Correct. False positives. FP. AI said yes, but it was no. Wrong. Like marking a good email as spam. False negatives. FN. AI said no, but it was yes. Wrong. Like missing an actual spam email. This matrix gives you a detailed report card of your AI's performance, showing you exactly where it succeeded and where it got confused. While accuracy, precision, and recall are crucial, they aren't the only things that matter. Speed, latency. How fast does your AI give an answer? For real-time applications, like self-driving cars, speed is critical. A slow AI is a bad AI, even if it's accurate. Fairness. Does your AI perform equally well for everyone, regardless of background, gender, or race? An AI that works great for one group but poorly for another is not fair and can cause serious problems. Interpretability, explainability. Can you understand why your AI made a particular decision? Sometimes, knowing the how is as important as the what, especially in critical fields like medicine or finance. Developers' perspective. As developers, we need to consider these broader impacts. A technically accurate AI that is slow, unfair, or a black box might not be suitable for deployment. Evaluating your AI isn't a one-time thing. It's an ongoing process, just like how you continuously update and improve your apps based on user feedback. Developers' perspective. Once you evaluate your AI using these metrics, you'll gain insights. My AI has high recall but low precision for X, or it's slow on Y type of data. These insights guide your next steps. 1. Collect more data. Maybe your AI needs more examples to learn from. 2. Tweak the model. Adjust its internal settings or even try a different AI model. 3. Refine features. Change how you prepare the data for the AI. This constant cycle of build to evaluate to improve is how you evolve a good AI into a great one. Keep iterating. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.